Good morning, students. My name is Abhishek Sachdeva. I am from Lalpur Khalsa College of Engineering, Department of Civil Engineering. So, today we are going to discuss the concrete mixed design proportioning process. So, yesterday's lecture was also related to the concrete mixed design. What are the journal requirements for the mixed design? And now we will discuss the proportioning process. So, what is basically the concrete mix design? We are discussing the journal parameters, and now we are discussing the proportioning process. Basically, what does this concrete mix design means? See, we are going to calculate the quantity of material. We are going to work out the quantity of the material for a desired strength. That means कि if we are going to design M20 or M25, so for that M20 or M25, we are calculating the quantity of the material in terms of cement or any other admixture to the replacement to cement, water content, fine aggregate content in kg per meter cube. Basically, cubic meter contents we are calculating. Then coarse aggregate content. So we are calculating the contents, material content, so that content it can be weighed and the concrete it may be prepared or it may be casted. So concrete mixed design means determination of the proportion of the concrete ingredients, that is water, cement, or any other admixture or mineral additive, for example fly ash, alkofine, it may be rice husk ash, fine aggregate, then coarse aggregate, which would produce concrete processing specified properties such as workability, strength, and durability with maximum overall economy. In yesterday's lecture also, we have discussed the concrete production, it should be economical. It should be economical, keeping in view the various specifications, the various parameters in such a way that parameters, that specifications, they are satisfied. So if we are preparing M20 grade of concrete, that means we have to attain the desired strength at 28 days, which will be tested by the compression testing procedure, and we should attain the proper workability, and the concrete it should be durable also. So with the passage of time it should not deteriorate. So this is basically the concrete mix design.
So, mixed design procedure, first step would be to get a mean strength. Characteristics: grade strength, quality control, that is your sigma, FCK, and this gives me mean strength. That's the first step. So we can look at the procedure of mixed design. First step is to get the mean strength. Then, strength is governed by water cement ratio. This is an empirical observation. First, by D.A. Abraham, sometime during 1920s, and this is still valid. We consider it, this is acceptable at all level, although there are other kind of approaches available, but generally strength versus water cement ratio relationship has been accepted, and it is understood that strength is largely governed by water cement ratio. So in mixed design procedure, we have now got the strength, therefore we can determine the water cement ratio. From the strength we can determine the water cement ratio, because water cement ratio governs this strength. But when all other things remaining constant, so this all other thing involves type of cement based on the chemical type of cement and age at which the strength is required. These are other factors. So age, strength and age both decides water cement. But we have also mentioned earlier in the previous lecture that durability of concrete also controlled through prescription of water cement ratio, depending upon type of cement. Now, for example, if you have an application or a site where sulfate attack, there's a possibility of sulfate attack, you might use a slag cement or sulfate resisting cement. Where you expect mass concreting to be done, heat of hydration may be a problem, you might use low heat cement. So if you use, let us say, sulfate resisting cement, the water cement ratio for sulfate resisting cement from durability point of view might be given or must be prescribed in the code. So the water cement ratio prescribed in the code for durability for given type of cement, which you choose depending upon the liability of chemical attack or size of the concrete mass. For example, if, as I said, if it is marine environment, possibly you will prefer a slag cement. An environment where sulfate attack is prominent, maybe sulfate resisting cement together with slag cement. Because if sulfate and chloride both are there, sulfate resisting cement is not good. So one is to, depending upon the kind of chemical attack you are likely to have, you choose the type of cement. Also, mass concrete you select low heat cement. If you want quick strength, then you might select rapid hardening RHPC, Portland cement, rapid hardening cement. Portland pozzolana cement for low heat, for mass concrete, and also for better durability. For example, alkali aggregate reaction, etc., etc. You might also select low alkali cement if it is alkali aggregate reaction. So type of cement depends upon liability of chemical attack and size of concrete masses. Now, water cement ratio is also prescribed from durability and from strength required at a given age. You find out the water cement ratio. For these two conditions together, durability, type of cement that is used for durability, and water cement ratio is prescribed for the given exposure condition. You find out the water cement ratio, finally select the water cement ratio. The selected from least of the two. First you see what is the water cement ratio required for strength, also the water cement ratio required for the type of cement for durability purpose. Whichever is lower, you select that water cement ratio. So first step in mixed design is to find the mean strength. Second step would be to find out the water cement ratio. This is a conventional mixed design. Most of the mixed design method follows this method. Second step would be to find out the water cement ratio. First is the mean strength, water cement ratio from the mean strength and durability concerns for the given type of cement and age at which the strength is. Right. Then followed from this, water cement ratio being known, second step. Third step would be to determine the water content or paste content. Method of compaction, size of the section and spacing of reinforcement. See, method of compaction decides workability. Size and spacing of the reinforcement also defines workability. That's what I said, which is specified normally. So required workability is specified from method of compaction, the section itself, and spacing of reinforcement. And then this workability is controlled by maximum size of aggregate and aggregate shape. Not really texture much, but shape, mostly the shape. Remember, when we discussed about aggregate, we said that maximum size of aggregate improves the packing density. Rounded aggregate or aggregate shapes improves the packing density. And therefore the amount of workability or the mobility, moldability required for concrete, which is a function of the paste content. So the paste content would govern the workability. That is what we mentioned in the previous class. So from the required workability, type of aggregate, maximum size of aggregate, and aggregate shape, etc., including grading of aggregate, we can determine the paste content. So overall grading and packing of aggregates, we can determine the paste content, and also either the paste content or the water content of the mix, because water cement ratio being fixed, if I choose amount of water, if I fix the amount of water, cement content will get automatically fixed. So most of the mix design method, what do they do? Based on amount of water, if I fix the amount of water, cement content will get automatically fixed. So most of the mix design method, what do they do? Based on the workability requirement, maximum size of aggregate, shape of the aggregate, and overall grading, determines the water content, which essentially ensures a required paste content. If I know the paste content, if I know the water content, then obviously I can find out the cement content. And if I know the cement content and water content in one, all the contents, cement content, water content, these are all expressed in terms of mass per unit meter cube of concrete. So in unit volume of concrete, how much of water, how much of cement I need, that I can find out. First I find out the mean strength. Corresponding to the mean strength, I find out the water cement ratio, and also look at the durability part of it. Whichever controls the water cement ratio, from that I fix the water cement ratio. Then if I can fix the water content, I have got the cement content also. The water content is fixed from water content per meter cube of concrete is fixed from workability, maximum size of aggregate, shape of the aggregate, and overall grading. In fact, that governs the paste content required, because the packing would be dependent upon the grading per proportion of the sizes, relative proportion of the sizes, and also shape and maximum size of aggregate. So this will depend the packing, and depending on the packing characteristics or packing density of the aggregate, the paste content required for a given workability would be, paste content required will govern the workability. So if I know the workability, I can actually find out paste content. But many mix design method, what it does, they fix the water content, because automatically water cement ratio being known, paste content will be controlled. So therefore, once the paste content is known, or in other words, water content, cement content is known, kg per meter cube, rest of, if I know the total density of the material, then I can find out, then wet density of the material, I can find out the aggregate content. Or if I know the total volume is 1 meter cube, if I know volume of these two component, rest of the volume is the aggregate content. So total aggregate content, therefore simultaneously I can find out. And if I know proportion of each size fraction, aggregate content, then I can find out mixed proportion. That is, every size fraction I should be knowing. So water cement ratios come from earlier, paste content and aggregate content being known, proportion of each size being known, I can find out the mixed proportion. Then I use this, knowing the capacity of the mixture, I find out weights of ingredients per batch. So this is the overall mixed proportioning process or mixed design process, as conventionally it is called. Actually, it is truly speaking, it is actually mixed proportioning. That's all we are doing. Design is conventional use. Perhaps it is more appropriate to call it mixed proportioning process. So this is the overall mixed proportioning process.
So this is the mixed proportioning process by which we are calculating, we are obtaining the various quantities per cubic meter. We are measuring various quantities. We are obtaining the various quantities per cubic meter. So aggregates, fine aggregate or the coarse aggregate, cement, admixtures, we are getting it in the kg per cubic meter. So this is the mixed proportioning process. Now, next is the requirements for concrete mix design. So basically, you have got an idea what is the process of the mix proportioning. So requirements, if we are talking about the requirements for concrete mix design, the grade designation giving the characteristic strength requirement of the concrete. So this will be the grade for which characteristic strength you are designing your concrete. For example, if you are designing the concrete for grade M30, so that means the 30, it is your characteristic strength. That is the strength which will be obtained at 28 days of curing. So that compressive strength, it will relate to your characteristic strength and the target mean strength. Next is the type of cement influences the rate of development of compressive strength of concrete. So it will be depending upon the type of cement or the type of admixture you are using along with the cement, or you are replacing the cement with any mineral admixture. So it will this will be the requirement for the concrete mixed design. It will be depending on the mixed design. Next is the maximum nominal size of aggregates to be used in concrete may be as large as possible within the limits prescribed by IS 456-2000. So in this code, Indian Standard 456-2000, the nominal size of the aggregates to be used in the concrete is specified. So depending upon that, we are going to calculate the aggregate quantity, and we are going to uh, grade the aggregates, because this grading of the aggregate, it is very important. The grading of the aggregate, it will be resulting into the density, it will be improving the packing density, it will be improving the workability parameters. So the nominal size of the aggregates is one of the requirements of concrete mix design. Next, the cement content is to be limited from shrinkage, cracking and creep. Cement content, it is very important factor in what quantity you are using the cement content in your particular grade of concrete. So as specified according to the Indian standards, the cement content is restricted, and this becomes an important requirement for concrete mix design. Then the workability of concrete for satisfactory placing and compaction is related to the size and shape of section, quantity and spacing of reinforcement, and technique used for transportation, placing and compaction. So again, The workability of the concrete, it is a requirement. We design the concrete based upon the workability requirement, slump requirement, the placing and the compaction. It is important how you are going to place and how you are going to compact the concrete in various sections of different shapes and sizes, and how you are going to transport or the place your concrete or compact your concrete in different sections. So these becomes a major important requirements for concrete mix design. So today students, this is all for the lecture. In the next lecture, we will continue the step-by-step procedure. We will discuss the step-by-step procedure for mixed design as per Indian standards. Thank you.